We need to show that the points 4, 3, 6, 4, 5, 6, and 3, 5 are the vertices of a square. So let us begin. So we begin by considering a quadrilateral first. Although it has the shape of a square, we're going to consider ABCD is a quadrilateral. And we will suppose that the vertices are having the coordinates. A is having coordinates 4, 3. B having vertices B having the coordinates 6, 4, C having the vertices 5, 6, and D had vertices 3, 5. Now, in order to show that the quadrilateral ABCD is a square, first we can show that all the sides are of equal length. That's a very simple task. We can use the distance formula to obtain the length of each of the sides. So let's begin by first computing the length of AB. So AB, what we'll do, we'll take the square root. Underneath the square root, first we need to take the square of the difference of the x coordinate. So what's the difference of the x coordinate? So that's simply 4 minus 6. And then add it to the square of the difference of the y coordinate. So here the y coordinates are 3 and 4. So the difference will be 3 minus 4. When we compute this value, this comes out to be equals to square root of 5. And similarly, using the same method of the distance formula, we'll see that BC, CD, and DA, all the three also going to have the length equals to square root of 5. So that means the sides of the quadrilateral A, B, C, and D, they are equal to each other. So, but we cannot say for sure that it is a square yet, because it could be a rhombus as well, because the four sides of a rhombus are also equal. So this is the first criterion. We have shown that the quadrilateral has equal sides. Next, what we'll do, we'll join the opposite vertices. That means we'll join A with C and B with D, and that's going to form the two diagonals of the quadrilateral. So here we have the diagonals AC and BD. Let's first compute the length of both AC as well as the length of BD. So the length of AC will again be using the distance formula. So that will be, we'll take the square root. Underneath the square root, we need the difference of the x coordinate. So that's 4 minus 5. We square it and then add it to the difference of the y coordinate squared. So that's 3 minus 6. We're going to square it. So 4 minus 5 squared, that's simply 1. 3 minus 6, that's negative 3, squaring it gives us 9. So that means this value is square root of 10. And then we will find out the length of the diagonal BD. So that's going to be, we'll take the square root. Now we need the difference of the x coordinate. So that's 6 minus 3 whole squared, and add it to the difference of the y coordinate, 4 minus 5, that's negative 1, and then we're going to square it. So this is also going to give us a length of square root of 10. So here we have obtained the second criterion, that the two lengths of the diagonals are equal in length. So this is criterion number 2. Fine. And then we'll come to the final criterion. That means if the diagonals of the quadrilateral are equal to each other, the third criterion will be they must intersect as well. Then we can say for sure that ABCD is definitely a square. So for this, we'll say, we'll first compute the midpoint of AC. To obtain the midpoint of AC, what we'll do, we'll take the sum of the x coordinates of the endpoints. So the endpoints are 4 and 5. Let's sum them up. We have 4 plus 5, and we're going to divide it by 2. Similarly, to find out the y coordinate, we will add up the y coordinates of the endpoints. So those are 3 and 6. We have 3 added to 6 and then divided by 2. So this gives us a value 9 over 2, 9 over 2. Okay, let's also compute the midpoint of the other diagonal B. So midpoint of diagonal BD will be 6 plus 3 over 2. That's the x coordinate, and the y coordinate will be 4 plus 5 over 2. So that means we have the coordinate points as 9 over 2 and 9 over 2. Now clearly we see that both of the two midpoints are equal. Since the midpoint of AC is equals to midpoint of BD, that means they are bisecting each other at a common point E. Fine. Now all the three criterions are met, and we can say from 1, 2, and 3. Let's write it down. From criterion 1, 2, and 3, we can now say for sure that ABCD is a square. That means a square is a quadrilateral whose sides are of equal length, the diagonals are also equal, and the two diagonals bisect each other.